Then this. Okay. So welcome to today's lesson. I think we'll just make a walkthrough of what we have been doing since we started, and we have had so many lessons, and we want to just run through in case maybe someone has just joined today, for example, and wants to understand, like he has maybe background in coding already, like using other softwares, so it should be easy to do with coding in R. So what you can do is you can go to, oh, sorry, let me go to the website. So you can go to website, just type any Google R download, to take you, and then ours is version 4.01, so you can go here. If you are using Windows, you can get this one, or if you are using Mac as well, you can just specify to say for Mac, and then it will come out. So if you go here, it will start downloading, but I'm not going to download it. So once you install that, it's up. And then you can also just put maybe for Mac, or if you are using Linux, you can also do the same. And then you can download this package. And once you install that, that means you have installed R. But you need, for Mac, you need to install this one as well. It's called Xquartz. So this one needs also to be installed. And then after that, you need to go to download RStudio. So download RStudio. You can, if you need, you can get the commercial one, but we always go for the free version. So which still gives you a lot of things to do, like for this level. But if you want to be managing servers or websites, because R can also be used to develop websites, then you need to go for these other, like the desktop, the paid one. But as you can see, it's still expensive, 995 per year. And then the Studio Saver one, which is super, super expensive. Yeah, and then you can click download on the free one, and then if you are using Mac, you get the download for Mac. If you are using Windows, you can see here operating system. So this is for Windows, and then this is for Mac, and then there is Ubuntu and the other softwares. Once you download that, you install it as well. Then you need to download R2s. So if you go to R2s, you get to download them for Windows. So you choose, mostly it's this one, which is for most of the machine except 64 bits. Once you do that, then you can open your R Studio. And once you open R Studio, you will be welcomed by an interface like this one. However, it will not be this color. And therefore, we can choose by clicking here. So if you click on this one, you go to pen layout, and then you go to appearance. So you can choose whichever you want. There are so many, the way R does appear, like the themes, I would say. So there are many themes, whichever you choose to be good for you, then you can pick that one. Okay, so for example, I will try to pick this one called Xcode. I will click apply and then hit OK. So it means the whole of my environment has changed to this. And the most important thing is to have a working directory. So you need to create a file where you're going to put everything in one folder so that we can be managing there. So you can set the working directory by going to sessions, and then set working directory, then choose directory. So if you click on that one, it will take you to wherever you want to set your working directory or the path. So for example, I will go to desktop. There is my folder there called Introduction to R. So I'll say, okay, open this, and then there is a code here. This code can be copied and then put here. And you can, the goodness is that you can create a script which can be shared, like cross-cutting. For example, we have colleagues that are outside the country or that are far away from you. You can always share the code with them, and then they'll be able to do, it's like a version control. You can do the same and push it to, if you have, for example, GitHub account, you can push it to GitHub, and then others can also control over there, and then you can always share the code with other friends and learn through the code. And the first thing would be to create a script like this. You go to this, and then you say, well, I need an R script. So here there are several. R script is just one long page document, and then R notebook is like a notebook. It contains several scripts. Then R Markdown, if you want to maybe create documents that are PDF in format or Word document, so you use R Markdown. And there's Shiny Web Application. If you are developing applications like that, you can apply to your, you can put in website. And you can also connect to Python, C++, and other programming languages. Or you can also get to write the documentation of R or some presentation and the like. So if you click, for example, script, it will give you a new script. And you can, this is where you write the code. So for example, if I copy this one, I will push here. That means I have set my working directory to this one. Now, you can, here as well, you can use manual to import things, or you can check the history, what programs are, what sort of analysis have you done before. As you can see, you can also export this one to a Word document, or you can copy them and put them in a Word document and share with someone. Then you can also connect it to maybe live data, for example, some visualization. You can make connections to data that, for example, I currently, we are in COVID era. So for example, the data is uploaded every time in the server. So you can connect this one to maybe national database server, and then you can be getting data like upon just clicking refresh, then you have all the analysis at once. If you also need a tutorial on how to do exploratory data analysis, then you can also consider this, which will help you a lot to learn maybe things that we will not cover here. Here it will take you to the files like in the folder you are. So in my folder, there are a lot of files because we created a lot of things. And here you'll be observing prots. From this side, you have what are known packages. So packages are like written algorithm or functions that makes work in R a bit easier. So for example, if you want to find sum of something, for example, or a summary statistics, you call some packages which are written functions that will help you to compute whatever you are computing. And then there is help function here. So help, you can get help in terms of R documentation and some examples as well for creating data and the like. Yeah, and then there is viewer. So whatever you get, you can view them, or if you can view them as HTML, like a file that is used to access mostly used in the websites. And this one is where you have, so this one is where you can write some commands directly, and where you will be getting your input. So that's what we started in short. So First of all, we need to remove everything into our space. So you need just to write remove, then you get whatever list you want to get, and then it will clear everything in your environment like here. So mine is already empty, so I don't need this one. And then I also talked about the packages. So I said packages are set of functions, but then you need to be connected to the internet in order for you to install the packages. And once you install the packages, it's one thing off. So you need just to decoding them by using a function called library. So if you, for example, you want to get Excel data, you need to use the package that will import Excel. How do you know? If, for example, I go to import here, so I will go to import and then I hit Excel, then here it tells you what package should be loaded in my system in order to read the data from Excel into R. So here I have Excel X. So I need to install that. If I need to import data from SAS as well, for example, I need to have a library called Haven. So if I click import, I'll get that. So this is what we did, and we had to install a library called read Excel and then library called Haven. Now the installation is you just write install.package. The goodness with the R Studio is once you write install like 3 letters, for example, in like that, and then for install, then the package comes, you just hit enter. So install packages, and then you put the name of the package. But I can also install all the packages once by putting a C and then put a list of packages having comma read XL and the right, and the list you can put the list. If you run this one, it will, but then it will complain because it will ask me that I'm going to like restart my R because the package that I'm using is prior. So I'll just cancel this one and then it will give me an error because I already have this one installed. And if I don't want this to be evaluated or executed by R, I'll need just to put a hash at the beginning, and then the whole of this one will be disregarded by R. So we stored several packages. We stored DDXL, Haven, TDVS, and Cable Extra. So TDVS, I said that this package is the most useful in data manipulation, where you can get summary statistics, you can get like outliers, or in it there are packages called ggplot. So I'll just run this one and know which packages are in there. So inside this, the package is called ggplot. There's a package called TDVS, TIBO. There's a package called TD, readr, power, deploy, string, and forecast. But then the system had already a package called, there is a confusion here, like it's conflicting. So a package called stats, there is a function called filter. And in the same package that I just said, TDVS, there is a sub package called deploy, which also has a function called filter. So that's why here it is complaining. And then it also says, oh, well, this TIBO, they upgraded it to R version 4.02. Where, as I said, I am using what? I'm using version, so if I do that, I said I'm using version 4.01, but R has already progressed to 4.02. That's why there is it's telling me a warning. It will do its function quite okay, but it just gives you a warning. Now, if I go to my desktop, I will find If I go to my desktop, I'll find, so let me modify it by find. So I'll go to desktop, I'll find folder called intro to R. If I open this folder, I have a lot of things inside that folder that have a data set called food, which is in CSV format. I'll try to open that data set. So this is the data set that is in there. And then I also have a data set called wash. So I have a data set called wash, this one. So, well, I get to get this data set. And we used this data set in generating all these two data sets were the most like eminent in all our data analysis course. So I need to get them into R. Since all of them are in CSV, I will just need to, okay. Here I demonstrated how to import data set that is in Excel format and that is in SPSS format. So mostly when we get data, we get it in various formats, but the Excel is most. I'll also demonstrate how to import from using the CSV file. So I read that library for Excel. Now, if I do Excel here, it will import data called food, which has 222 observations. But if I do this data called wash, which has which is from SPSS, then I'll get a problem here. It says error in this one could not find function lead cell. So why this function is not available is because I did not call this library called Haven, which has that function. So if I do that, and then I do these two, then I do this now, it should work. I get a data set called wash that has 596 observations with 72 variables. Now, I would just check a frequency like how, okay, in this data set called wash, how many people, how often do people treat their water? So if I use a function called table, then a data set name, and then once you put a $sign, it comes automatically. So like if you just do table, and then the data set is called wash, I put a $sign. And then if, for example, I put gender respondents, I want to just see how many were females, how many were male. If I run that, then I need to know though that from my questionnaire, I need to know the coding that 0 means female, male, 1 means female. So prior, I need to know that. Then I can also view my data set. I can view it by just clicking here. It will take me to my data set. If I click on this one also, it will take me to my data set. Or I can use the function called view. So if I use the function called view, it will take me to my data set. So otherwise we don't need it. I'll just put a comment here. Now we can also get to know descriptive statistics, but mostly you should be able to know what are the column values. So for example, here it's group, district name, own at least one cow, income, and the right. Now, how do you happen to only show these variable columns? The columns in R. So you use column names. So once you use column names for food, it will tell you, okay, in this data set called food, I have these variables. So I have up to here. We can do similarly for wash. So if I do column name and then wash, that is wash. If I do that, I'll find that wash has about 72 variables. So all of these. And the goodness is you can always put this one up here and then view all of them. Unfortunately, I can't because they are main. So you can always drag this one and the like. Now we want to get a summary statistics for income in 2012 from dataset code food. If I learn that, I get the minimum income was 6,300 Kenyan shillings because this data was from Kenya. I'm assuming that's their currency. And then the first quartile, the median, the mean, the third quartile, 75 percentile, and then the maximum. So the maximum was 16,400 Kenyan shilling for these farmers in Kenya. Similarly, I would get some summary statistics for age. So the minimum, so this is from WASH data. The minimum age was 12. So WASH data was, there was a survey done where I live in Neno, and we had to collect information on the age of the respondents. So we said, we told the enumerators that when you go, do not ask anyone that is below 15, but you would still realize that when they visited maybe a household, they only find a child-headed household. So they had to ask them. And so here you would see that the mean average is around 38. And it's also worrisome that they asked someone who is 93 years old, because I don't think the information that they captured in this household was more, maybe. And excuse me, so we can also get information on their education level. So like those that did not any education or primary, secondary, and tertiary. So we only had 5 people that had up to tertiary education. Now, once you do the table, you can get the proportion. Now you want to get the proportion like percentages. So the same here, you will need just to start by the table itself. So WASH, and I will get the proportion of household head, for example. Okay, so if I do that, I find that 181 were female-headed household, 411 were male-headed household, and 2 were child-headed household. 4 were child-headed household. I want to put in proportion. So I will just, the same code, I will just put prop dot table, and then I remove this and I put here. So proportion dot table, if I do that, I get it that this was around what? 0.3, and this was around 0.3, and then this one was around 69%, and this one was, about 0.6. So I can multiply this by 100 just to have them in percentage. So this is 30%, 68.9, and 0.6. And then I need to just round this one up. So I will say round this one at least by 1 decimal point. So if I do that, then I get the figure rounded up. So we did this same, but it was for education. So if I do that, I get that. And then we realize that data is captured in many ways. So data it can be stored in form of text. So text shall mean like characters. For example, if you are capturing names of people, I think that information will be stored as characters or text. So we have Moses and Aaron Yeah, it's captured as a text. If you are capturing age, age will be stored as a number. So you have 13 years, 17, 20, 25, 40, 80, and the like. And if you are capturing information in terms of, say, for example, gender, it will be stored as a number, but can also be stored as a text, but can also be stored as a factor. So a factor is where a number represents something. For example, you will say 0 represents female and 1 represents male, or 0 represents male and 1 represents female. Now, you have imported the data into the system. How do you know that this information is stored as what? And you can always change format from one aspect to the other aspect. So you do use a function called class. So in the food, there is a variable called district name. And if I want to get the class of that, like what type of variable is that? Does it store character or does it store numeric, or which can be more like categorical as well as it can be categorical as well as double, like floating, which has some decimal points. So similarly, we checked for income in 2012, we realized that that's a numeric, while the first one was character. And you can do the same in WASH. So for example, if I say, okay, let me get class of WASH data, and whichever I choose here will be okay. Let me get total children aged 5 to 17 years old. So if I do that, it tells me this one is also numeric because there are number of children. Now, you can, for demonstration sake, we said you can always change data from one point to the other. Now we had to export data, and you can use several. You can go to you can go to just write the code, as in write CSV, and then you get to a CSV file. And the importing part, we can also like import from the way I was trying on the other aspect. So you can write this one as in export, sorry, write, here we are exporting the data. So if I write CSV, the data, I'm picking my data set called wash, and then the output will be wash.csv. So if I do that, it will write my data set. And if I go to my folder here, the folder that I am called intro to R, I'll find my data set called wash.csv. I can re-import that. So remember that the library code Haven is already installed, so we are okay. I will import that data into this variable called Mazi. Then once I do that, not variable, but the data set. So if I do that, then we'll be okay. And once I do that, I have my data set here. It's the same data set. We had just to export, and then now we are importing. And then in this data set, it's a large data set. I want just to use some variables from that data set. I want a variable code, household, gender, age, education level, household head, and total number, our total household members. So I will use wash, and then remember I said here there was a conflicting messages when I tried to run here. There was a message here. There's a deploy that gets filter conflict message. So filter is from this package, is also from this package called stats. So R is complaining. However, if you want to specify, for example, if I want to specify to say, okay, this filter, I'm using this filter from a package called deploy. So I will need to use this as a function. So that's why here I said, okay, from this data set, I want you to extract only columns, these variables, and then select these variables and install it into a new data set called wash. But then how do you select? I use a function from a package called deploy. So I would specify like this. And here it doesn't matter. You can format it the way you like it. So for example, if I format it this way, it will still be okay. Like this, it doesn't necessarily matter. And I would encourage you for readability sake, you can format it that way so that someone like know exactly. So this is the name of the data set, and then these are the variables that we are extracting, and then we are pushing them to this data set by using this little pipe, which is less than with a dash or a minus sign. So if I do that, it will be still okay. I get this one. Now we have reduced the observation only to 6 rather. So the household ID, the gender, the age, the education level, the household head, and the total number of people in the household. Yet the first one had a lot of variables. So, and then we can also shorten, if you go here, you find that this is household ID. We can just make this ID, this is gender, this is age, this is age level, maybe age, education level, just age. Then this is household, you can name this HH and total number of household members. So that's what we are doing here. You will use a variable, we will use a function called rename, and that's what we are doing. We are renaming from this data set. Wherever we will see household, where we will see age level, put education, sorry, age level, put age. And total household members, put HH members. So I run this one as well. I get that. If I go here, I find that now my has changed, all the variables. And I can get the summary statistics for age. We already did that one. And then I said, as I said, this survey was commissioned to ask all people that are above 15 and only those that are less than 60. So I can filter to say, okay, disregard everyone who was below 15 and disregard everyone that was above 15. As you will see here that we had someone who was 92 and the minimum was 12. Or if you go to the data set, to the actual data set, which is WASH 1, and then just click here, sorry, on age, you find that we had this person who was 14, 12, 14, 14, 16, 16. So we had 3 people that were below 15. If you do the other way, you find that a good number of people that were above 60 years. So all of these were not needed up to here. So you just say, okay, get a new data set or install a new data set where I only need people that are above 15 and below 60. So I will filter that and I get to, from 956, I get to 596, I get to 536 observation. Once I do that, I get the summary stats. I can also get the table. Then here, sex, no one can tell unless we are told. So 0 and 1. But what is 0 and what is 1? So you can change the code for sex from 0 to 1. That's what we are doing here. So we're saying in the dataset code WASH, there is a variable called sex. And wherever this variable called sex is equal to 0, make it male. And whenever it is equal to 1, make it female. So if I do that, And I do that, and then I get table. Now it will be able to tell me female and male. So we did the same for education. We got done primary, secondary, and tertiary. Okay. We did for the same for the household head. Okay. And we got yes or no. And well, how about if we break the age group into, say, those that are 15 to 30 and 31 to 45 and 46 plus. So we can use the if-else conditions, or we can use mutate. So mutate is only available in a package called PDFS. That's where you get this function called mutate. But as R, you can also use if-else. So here you say, okay, generate a new variable called age category from this data set, okay? And this age category will be equal to, like we'll have a breakdown where age is in between 15 to 30, give it 15 to 30. Where it's in between 31 to 45, give it that way, or else give it 45 plus. Similarly, you can do if age is greater than or equal to 15 and age is less than or equal to 30, then make it that way, 15 to 35, or 31 to 45, or 46. Otherwise, it should introduce missing values, where it's represented by n. So if I do that, it's the same as doing this. They should give us the same. And we can also do a cross tabulation. So cross tabulation, you want to see like how does the distribution is like in two variables. For example, education. How is education distributed in sex? Or how does sex, or how is sex distributed in education level? I want to see how many males and how many females were in each of the categories of education. So if I do that, I see, okay, there were 62. You just use the same table and then specify the 2 with a comma in between. So I'll see, okay, there were 62 males and 62 and 25 females that did, 62 females and 25 males that did not go to school. In tertiary education, we had that one as well. If we swap the two, for example, I'll just swap the two, and then I get this one as sex. It will be more like the same. It will communicate the same message. So 62 did not do any school, 235 had primary, 85 had secondary, tertiary. But it's all the same. And then here we started creating graphs using a ggplot. So ggplot function, you need to get data. Which data are we referring to? So we refer to data called wash, and then it gives you an aesthetic, like a geometric figure that has coordinates. And so we had to fill it by sex, and then the horizontal or the x-axis should be equal to education. And then this should be bar. So we want a bar graph where it says position equal to stack, that you want them one on top of the other. Otherwise, if you change this one to dodge, then that will be side by side. And then Gigi title, you put a label. That's the distribution of the respondents by sex. Then you can put a subtitle. You can put the label of x-axis, the label of y-axis also, and you can adjust the color or the theme, and you can also include variables. So if I do this, there we go. You generate a graph like this. How about if I change here to dodged, and then I go it as a side by side. But however, The numbers will still remain confusion because I was positioning them here. So this one tells me how to position the numbers. That's why this one is still stuck up there. I think for the sake of time, I will not change anything. And then you can also group. For example, I'll group by sex and then get summary statistics for each of age. What was the age distribution in sex? Like what was the mean age for males and what was the mean age for females? What was the minimum age for males and what was the minimum age for females? So if I do this and then I use a function from the cable extra package, this package called cable extra, then it gives something like this, which is more visual. I mean, looks okay. And we have that. And then we continue with the box plot, which is more of the same with the history, the bar graph that we created. So GGG, the data set is called WASH. And then the John box plot, we feed it by education. So that is the x-axis. And then Y is the age of the respondents. And then we feed it by sex, like male separate from females. And we add the title, the x-axis label, the y-axis label, and the theme. You can always check the theme and get them. Similarly, we did a histogram. So that's the base histogram, and this is how it got modified. And here as well, we did the renaming just like it was before. Rename food, where it's written group, put group, where it's written this district name, just put district. Own at least one cow, own cow, and the right. So I already demonstrated how to do that. And how do you get a scatter plot? So you can just put plot, a plain scatter plot will look like this. The food saving in 2012 and food saving in 2013. But then if you use a ggplot, you can get a good scatter plot, which will maybe look a bit nice compared to the other one. And here we have done separate for each, like district, Busia, and Butere, because there is this function called facet. For example, if I remove this facet and I run it, it will only be in one scatter diagram. So if I put it back, and then I run that, I get that. So similarly, it's the same with that. It was a histogram for each of the facets. Then we also saw a stem plot, which produced something like this is the stem, and then these are leaves. For those that understand statistics, we did some stem and leaf plots, like some basics. Yeah. And then you can also generate a variable called, for example, age 2, where you are multiplying the age of the person by 1.5. So here I was demonstrating just to say, well, you can change the stem as well. It cannot be only 0, 0, 0 like it was before. So it would look something like that. Then we had to go to pie charts, and we got some pie charts. So in pie charts, it's a bit tricky. First of all, you have to get the data set. Like in this context, it's a WASH education. If I get the table, this is what we have found. And then I need to create a variable called WASH-pie, which will get data from my WASH3 data set, but we will remove those that had education, especially because we only have 5 people. And then it will group the data set by education, and then it will count how many in each, then and group that and then we will arrange it in descending order. And then we will create a variable called percentage, which will, percentage is like round. So, I mean, how many are in primary divided by total in primary. Okay. How many are in primary divided by the sum of the total. So 87 divided by sum of these. And that's what we are doing here. And to get percentage of that, you multiply by 100. So that's like having a cumulative sum. So that's what we are doing here. And if I do that, I go to pie chart. Now I will no longer use this wash over 3. I will use this new wash pie, the data set that I have just created. If I do that, and then I get a very beautiful chart here. So maybe just something to mention here is here I'm including variable which is from percentage, and then I'm putting this percentage which should be separated by like a space here. And then the color of the numbers inside the pie chart should be black. And I am using what is known as color brewer. So it's also packaged, but it comes with the R, or you can also install the latest one. And then I put my GG title as well as my my key or region. And we did that. Then we also looked at correlation and correlation test. So what's the correlation between savings in 2012 and savings in 2014? Is there any relationship? So correlation, we got it at 0.8, which was a positive one. Simply, we can say there's a relationship between two, or there's a correlation at least between the two, a positive correlation. And then we had to do a testing whether that correlation is statistically significant. So we did that, and then we also performed the chi-square test of associations. This is more of a statistical test as well. And we had to find p-value. So like in this context, we find a p-value which is very small, and therefore we would say the correlation is statistically significant in that context. Just like here it says true correlation is not equal to 0. Okay, so if the p-value is smaller, that means we reject our null hypothesis and conclude that the correlation here, the true correlation is not equal to 0. And similarly for the Pearson chi-square test of the association, is there association between gender or sex and being a household head? So we did that, and we realized that we got a p-value which is much, much smaller. So there is association between gender and household. Most likely, if it's man, then they tend to be like maybe from the African context, they tend to be the household heads, except for other countries. So we also produced a donut chart. A donut chart is more of the same pie chart, only that it has a hole in between. And this was the code that we ran. And we also utilize the data set that is in the system. For example, the data set called MPG. So MPG is the data set that is available in the system. And here in this lesson, we demonstrated bit by bit on how the ggplot operates. It was like a reminder of how we did create all the, but using the data set that is available in R if you don't have your own data set. So that's what we did all of these. We created line charts. So we created some dots or scatter plots, and then we created some scatter plots for each of the cars. And then we also had some line charts. We also had a data set called Diamond. So we created some stacked bar chart, which were more like looking fancy, but have sometimes difficult in terms of viewing which one is which one. And then we loaded more packages. For example, a package called mass was loaded. And then we also have a data set called survey. So we attached this one as well. And we had to view and then summarize the height. So here we were doing some test statistics like t-test. So like here we tested the sample. Someone is claiming that the mean height is equal to 170. Now you need to test that assumption using t-test. So we did that, and then we realized here we find our p-value, which was much, much smaller. And therefore, if it's much, much smaller, we rejected the null hypothesis and conclude that the true mean is not equal to 170. And then we also grouped to say, okay, how about for two samples? So is the mean difference in males that much different from those in females? So we also got a p-value here, which was much smaller, and we concluded that true difference in means is not equal to 0 between these two. And then here it's just kind of repetition, rewriting data set in separate. So here I had only those that did primary, only those that did secondary, and only those that did secondary education. And then here we were trying to learn about how to make data sets. So using R-bind, like you get data set number 3 and data set number 1 and then combine together. As I said, sometimes when you run a survey, you realize that you collect information from different sources and then you have to combine these and put into one data set that you can analyze. So this is where we are just utilizing the full join, for example, or left join, and we combined all those data sets. And then the last part, after the lesson that we received from Fishan Kondowe, who helped us with a t-test, we had the lesson on t-test, which was just learning how to write the narrow hypothesis as well as learning how to write the alternative hypothesis. So as you would see here, that my alternative hypothesis was that the mean age of man is not equal to, so like the alternative. So it's the same like what R gives you. So it's like the alternative hypothesis was already written from the background by R. So we also did group by gender. I already demonstrated on top there. And I think the last part was performing the analysis of variance. So we did the analysis of variance and get some summary statistics. So that where we realized that we generated a p-value which was a bit high, and conclude to say that we failed to reject our null hypothesis. The null hypothesis in the analysis of variance says that at least one of the means, okay, is equal. Or I mean, there is no difference in means. However, for the alternative, we will say that at least one of the means is different. So analysis of variance is more like a t-test, but for groups like more than 2. So if you perform analysis of variance for gender, for example, male and female, is the same as just doing a t-test for independent samples. But if you analyze the analysis of variance for education, so you have those that the mean, for example, the mean score for those that maybe were in lower grade and those that are in upper class, for example. So you have like 3, in short, you have more than 2 categories. Now you try to compare the mean in those categories. And the null hypothesis is that the means are not different from each other, while the alternative hypothesis says that the means are, at least one mean is different from the other. So this is how far we had gone with the analysis. I hope today was just an overview of what we've done since we started the lesson. And I'm hoping to continue the lesson, but maybe for the lessons that are coming, it will be a bit difficult to understand for those that don't have like a background in statistics, because we'll be doing something like logistic regression, or untested assumptions, generating odds ratios, adjusted odds ratios, and etc. And then we also will embark on a journey on survival analysis to understand like hazards, proportional hazards, or adjusted hazards ratios, and things like those, which will be difficult for those maybe that don't have a background in statistics or something related to like computer science or part 3, and maybe like those that did some economics. Otherwise, thank you so much for having me. I hope I will upload this to the drive, and you can always access there. Should you have any questions, I'm available, though not much, but at least I can address some of the questions that you might raise. And let me stop here for today.